Okay. So there are few questions that I had received from Isha, so that she wanted me to solve those, and we have been trying to solve those. But the good thing is, there's one topic that we have not covered in detail in Unit 12, and that is around quadratic functions, polynomial functions. Then let me read it for you guys. So I have sent that in the message today. That the other thing that we are going to cover. So if you look at these, the topics that we are going to cover are using quadratic formulas to solve equations, understanding discriminants in the number of solutions, absolute value equations, quadratic and exponential word problems, and then exponential graphs and polynomial and non-linear graphs. So a lot of topics actually. So basically now when I went through this unit, I realized that there are a lot more things that we still have to learn, which we have not, and that is probably the reason why when we were trying to solve these problems, we were kind of having a tougher time. Okay. So let's go through those one by one, and then we'll come back to the questions that Isha had put across. Okay, that's fine. So let's look at some of the things that I had shared with Isha. And I keep telling Isha's name. The reason being, Isha is one of the students who keeps me busy, and I want to be busy. Okay, so when you guys send me questions, when you guys send me some problems to solve, that is what kind of gets me out of my comfort zone and figure out if there is something that I need to explain you guys. Okay, so that's the request for each one of you. Like the way Isha keeps reaching out to me saying, "Uncle, sir, I want this problem to be solved." That is when we get to realize that okay, there are certain things that we have to learn. Okay? So same thing applies for all of you. Keep reaching out to me wherever you find something interesting, difficult, not known kind of thing. Okay? So let's go one by one. Let's not waste too much time. So let's start with the basic quadratic functions. Okay. Let's say my function is y, or quadratic equation is y equals to 5x squared plus 2x plus 7. Okay. Or you say y is a function of x, which is this. This quadratic function that we have seen, right? Likewise, every function or equation which has power 2, up to power 2 is quadratic function. Yeah? And we can graph it like this. So let's say we plotted the graph, we found some value and plotted this graph. Okay? Let's say this is a parabola. This is the graph or parabola that we plotted here. Why it is facing upside down? Why it is facing upward? Because this is positive. Okay? If this is the coefficient of x square is positive, it will be facing upward. That part we have seen, right? If it is negative, it will be facing downward. Okay. Now let's say, so y, which is a function of x, with this quadratic function is like this. Let's say, if I find another function which is negative of this, what does it mean? Meaning, if I say this function of x which is negative, meaning let's say I have function y is equal to function x as this much. If I say another function which is, let's say, y1, which is it's negative of this function, what does it mean? Meaning whatever is the value of x you get, I mean for whatever value of x you get y, I am getting a negative value of y. Let's say here x equals to 2. What is the value? 2 squared into 4, 5. 20 plus 4 plus 7. So 24 plus 7, 31. Now, if I say x is, I'm trying to find out negative of this value, negative of 31. That is when I say there is a function, another function, quadratic function, which is negative of this one. Meaning whatever would have been the value for this, I want a negative of that. What does it mean? Here, look at this. For value of 2, when x equals to 2, I got value of y as 31. What I am saying here, I am saying minus of function x, minus of this. What will be that? So I am saying y equals to minus 31. Yeah? Meaning it will be somewhere here. Let's say if y is, let's say this is my parabola, okay, with this equation. Now I am saying negative of that. What that means is the value of y, whichever was positive here, that is totally negative here. It will be reversing this thing. And it uses your x-axis as your mirror. Yeah. So that's the first thing that I have not sent that to each one of you. Let me forward that to everybody in the group. And then we'll go through that one by one, just to build that understanding so that it helps us solve it better. So, this is one of the scenarios. So let's go one by one. There are total 7 scenarios that we have to look at, so that we can understand how the functions translate into outcome as a graph. Let's say the first one. This is graph of y equals to function of x minus c. So let me not do this. I will say y equals to x plus c, y is to x minus c, y equals to function of x plus c, y equals to function of x minus c. Let's try relating these scenarios, what it means. Let's say I have a function y equals y as function of x at x squared plus 2x. Okay? Now, if I change x in place of x plus c, what happens to the graph? Let's say this is my graph, which is plotting function of x. This is x squared plus 2x. Let's say this is what it has plotted. If I change the value of x from x to x plus c, what will happen to this graph? Any guesses? See, again, it's not about guessing it. I'm just trying to help you guys visualize. So I have a graph which says I have a quadratic graph with a quadratic function y equals to x squared plus 2x. Okay, this is what it is. If I change the value of x from x to x plus c, what will happen to this graph? Let's look at, let's say this is the vertex, okay, and this is the lowest point of this one, right? So let's say let's keep it simple for now. Y equals to x squared plus 2. So when x is 0, y is 2. So it is touching y axis somewhere at 0, 2. Okay. Now we are trying to find out the vertex. The lowest point of, okay, now we found this one. Um, what is that?
Find the estimation of the vertex by doing negative b by 2 times.
Okay, so that will come true. Yeah. What is that?
Negative b by 2 times.
Yes. Correct. So we'll come to that one. There's a formula for that one. So when you solve a quadratic function, quadratic equation, let's say you have equation as x squared plus bx plus c equals 0. When you solve this one, value of x will be minus b plus minus b squared minus 4ac by 2a. Okay. So this is one thing that you have to learn, but we'll come to that one. So for now, I'm parking this one. So Pranath is giving a formula that the vertex, x coordinate for the vertex will be x will be equal to 2b by
b over 2 times a and it will be
minus b by 2a. Yes. So this aligns with this formula, minus b plus minus b squared minus 4ac by 2a. And then when this value is 0, you have only one solution. That's how it aligns with minus b by 2a. Okay. So now here, what is b and what is a? My b is 2 and value of a is 1, 2 into 1. Right? So s coordinate of this one is minus 1. Okay. So I think I got lost here. Let's keep it simple for now. This is my, let's say y equals to x squared plus 4x. When x is 0, y is 0. Okay. This is my parabola. Okay? Now, when I say instead of x equals to instead of x, if I say x plus c, what happens to this parabola? So let's here in this case, if I say x plus c, what will happen? X plus c squared plus 4 into x plus c. Okay. Now here, what is the so we'll use this one. S coordinate of parabola is the vertex is minus b by 2a. Okay. So here in this equation, look at this. What is the S coordinate of the vertex? It is minus b. B is 4 minus 4 by 2 into a. 2 into a is 1 minus 2. So x coordinate is minus 2. It's somewhere here. Okay. Now, if I say, if I put this equation, right? Okay. Yeah, I think I have a better way to prove this mathematically. Whatever we have done, just forget it. Let's do it mathematically. Okay. Here the fourth equation that we're talking about. One scenario when my function has something added inside it. So instead of a function of x, it's function s plus c. Second is function of x minus c. Meaning in the x coordinate, when I change something, what happens? When what will be the value of y? If in the function of adding, I'm adding this thing as a constant in the equation. And when I'm subtracting this, what happens to my parabola? Okay? So let's look at this equation, y equals to 2x squared plus 4. Let's say this is my parabola, okay? Now we look at all these four scenarios and find out what it is. What happens with x plus c? Or I will not say c, I will say 2 or 3. what we are trying to find out is, I have a quadratic function. If in the function, instead of x, if I add something or subtract something, or if I add or subtract the value in the overall this thing, instead of moving just changing the value of x coordinate, what happens to the parabola? So let's look at this one. One thing that we know is the x coordinate of the parabola is minus b by 2a. Then my equation is in the form of ax squared plus bx plus c. Okay. Here a is 2 and b is, so this is not b. B is actually 0. So I will say 4x so that we don't have confusion here. A is 2 and b is equals to 4. Okay. So my x coordinate is what? Minus x coordinate of the vertex, okay, is minus 4 by 2. That is minus 2. That means this is my parabola and the vertex, x coordinate of the vertex is minus 2. Meaning it's somewhere here. This is how it is. It is touching the x-axis at minus 2. Yeah? Right?
For the vertex, so probably the issue that you find the y value.
Okay. So, okay, let's look at this one then. You are saying this is not the formula. Let's just assume this is the formula. Even if we assume this is the formula, what happens? Okay. We'll come back to the formula a little bit later. So, vertex, let's assume that this is the formula, okay, for the x coordinate of the vertex. So in this case, what is the x coordinate for the vertex? Minus 4 by 2 into 1, 2 into 2, that is minus 1. So it's touching the x-axis at minus 1. Okay. Now we are saying, what will be the value for, what will be the situation with this one? So in this function, what will I do? If y1 is a function of x plus 3, okay, so what will happen? Here I will put, instead of x I will put x plus 3, plus instead of x I will put x plus 3. This becomes 2x squared plus 6 into 2, 12x plus 9 into 2, 18 plus 4x plus 12. So here it will be 2x squared plus 12x plus 4x, 16x plus 30. So this becomes my equation. In this case, what will be my vertex? X coordinate of the vertex. What is the x coordinate of the vertex here in this case? It will be again same thing, b by 2a. What is minus b? Minus 16 by 2a is minus 4. So it is minus 4. Okay. Now, what happened? When my vertex was minus 1, what did I do? I put x plus 3. It moved from minus 1 to minus 4. My x coordinate moved by minus 3. It is confusing, right? Okay. Let's go step by step. What am I doing so far? I have a quadratic function x square y equals to 2x squared plus 4. Okay? And I have assumed that this might be a little different, despite not being clear, we will find it out. I have said that if I have an equation like this, for any quadratic equation, the x coordinate of my vertex is minus b by 2a. So here a is 2 and b is 4. A is the coefficient of x squared, b is the coefficient of x, and c is the coefficient of the constant c, if you have any. So here we have only a and b. Okay. So x coordinate is minus b by 2a. Okay. So that is how with this equation we found out what is the x coordinate. Where is the vertex? It's minus 1. So it's somewhere here minus 1. Now, we said, okay, what will be the value if I change the function from a function of x to function x plus 3? What did I do? I replaced x with x plus 3 everywhere. What it became? It became a equation like this. 2x squared plus 16x plus 30. So from this, again I try to find out for this equation, what will be my vertex? I found my vertex using the same formula, minus b by 2a, as minus 4. So earlier my x coordinate was minus 1, now my x coordinate became minus 4. So whatever number I had added here, by that many points it moved to the left. So here the interpretation is, if you have a function like this, and if you have to find out what will happen if you use x plus something. If you say x plus 2, it will move the graph, the whole parabola by 2 points. So you are picking up the vertex is moving by 2 points. Everything moves by 2 points or to the left. Same way, if you do function of x minus 3, parabola moves by 3 points this side. Confusing? Okay. So first of all, let's look at what is that we are trying to do. I have a parabola. I have drawn it here. Okay. And from this parabola, we have found out what is the vertex. My vertex is my x coordinate of the vertex is minus 1. Okay. Let's say by some means we have found it out. Okay. Yeah. Now we are saying, what will happen if instead of function of x, if I go for function of x plus 3? So from this one, applying the same logic, we found that if you go for function of x plus 3, my x coordinate of the vertex changes from minus 1 to minus 4. So whatever points we added here, plus it shifted by that many points to the left. If I do x minus 3, meaning I am subtracting, it is moving by 3 points to the right. So that will be your interpretation, okay? So this has not explained, I mean, if you go to Khan Academy, right, it has not explained it that way. We were just trying to prove it, that okay, if I have function of x equals to y function of x, which is equals to x squared plus 4x plus 7, and then that draws the parabola. If I go for function of x plus 6, what will happen? Function of x will move the parabola by 6 points. So every point on this parabola will move by 6 points to the left because we have added 6. If I say what will be the function of x minus 5 for this equation? So we are saying minus 5. That means it is going to move right. Everything will shift to the right by 5 points, including the vertex, including the point where it touches the x-axis. It will move horizontally. So in the function, if you add or subtract something, it moves the parabola to the left or to the right. If you are adding, it moves to the left. If you are subtracting, it moves to the right. That's the interpretation. Are you guys with me so far? Yeah? I know it was getting a little confusing in the beginning, and that's how you guys opted to hide. So yeah, turn on your video, that's what I was asking for. Okay, so this part is okay, right? Dhanushri, are you okay with this, whatever I explained? Okay. So, very simply put, I have an equation for a parabola. If I'm adding something like this, if instead of function of x, if I go for function of x plus 7 will move it left. Function of x minus 8 will move by 8 points to the right. So there are questions that I have seen where you are given a function for a parabola, and then they say, okay, if I go for function of x minus 5, what will be which one is the right option? So you will just look at, okay, it's minus 5, so everything is moving by 5 points. You will pick up 1 point and see which one is moving by that many points. That will be your answer. There is no calculation needed. Whatever effort we have put here is only for getting the right understanding about this one. So for function of x plus 3x minus 3 kind of situation, you are clear, right? This is doing lateral movement, moving it horizontally, left or right, depending on whether you are adding or subtracting. Is that okay? Yeah? Okay. Now, let's look at the other two. And Isha, you must be thinking that sir is not solving the problem, he is taking us to all the places. But trust me, just wait for some more time, you will see why I am going through all this. Okay? Yeah? Okay. Now comes what happens. I am not adding this in the function itself. I am adding additional coefficient. What happens to that? It moves it upward or downward. So this is, let's say this is your parabola. Okay? And let's say this is your vertex. When you say add something by 3, very simply if you can look at it, my value of the y coordinate is increasing by 3. Let's say my function is like this, 4x squared plus 7x, let's say. Okay? I am adding, now say okay, I will go for a y1, a new function, which is function of x plus 3. Now look at, for the same value of x, what happens to y? Y changes by 3, that we have added here. Let's say when we go for x equals to 1, in this function, what was the case? When x is 1, it was 4 into 1 square, 4 plus 7, 11. Y was equal to 11 when x was 1. Now look at this one, same scenario. My function has become y1 equal to x plus 3. So 4x squared plus 7x plus 3, because I am not making this x as x plus 3, I am adding a constant outside. Okay? Now look at this. In this case, when x is 1, what happens? When x is equal to 1, what is the value of y? Y is 4 into x squared, 4 into 1 plus 7 to x. 4 plus 7, 11 plus 3, 14. See? The same point which was 1 and 11 now it became 1 and 14. The y coordinate value changed by 3. It moved up. So whenever you are adding a constant in the equation, it moves your parabola by 3 points up or down. If you are adding, it moves up. If you are subtracting, it moves down. So here, these 4 properties that we have looked at, this only gives us a visual understanding of what happens to my parabola. I have a quadratic equation for a parabola. If I am adding in the variable itself, I am making function of x as function of x plus 3, it moves it to the left by 3 points. If I am subtracting in the function from variable changes from x to x minus 3, it moves it to the right by 3 points. If I am adding a constant in the function, I am creating a new function where new function is old function plus 3. I am not saying x plus 3, I am saying function of x plus 3. Okay? So, in that case, it is making my parabola move up or down. So, when it is plus, it moves up. When minus, it moves down. And what I mean is, the whole parabola, every point on the whole parabola, let's say. Now, let's look at the visual effects before we go to the next one. And you guys will be little surprised to know it took me like one and a half hour to visualize it for myself. Though I am able to explain that in 15 minutes, but it took me 15 minutes to visualize it. Yeah. Yes. So that's another way of doing it. So we are just speaking of one example to visualize how it happens. Okay? Now you have 3 forms. You have vertex form, you have intercept form, you have standard form. And you can pick any form, put the value, the outcome will be the same. Okay? So you have three ways to prove whatever we are seeing here. Whenever you want to convince yourself that okay, sir told that by adding up 3 or 4 after the function, it moves it up by 4 points. Everything moves up by 4 points. Let me see that. So here's the thing. Look at this parabola. This is, let's say, my parabola. If I'm saying which is function of x or y equals to, let's say, x squared plus 3. This is my parabola. If somebody says function of x plus 5, first thing that will come to your mind is, oh, function of x plus 5. So this is talking about moving it laterally, this way or this way. Now since this is plus 5, this moves by 5 points. So this one, let's say, was x, it becomes this minus 5 because it's moving to that side, right? So x minus 5. The coordinate changes. This moved by that many points. So whatever was the coordinate here, that and this one is different by 5 points. Okay? Now, if it is x minus 5, then you know that this parabola is moving in this direction. It comes here. Every point changes by 5 points. Yeah? Now, same thing. If you look at your parabola, this is a parabola which is function of x or y equal to function of x is x squared plus 7x, and then says my new function is function of x minus 18. This guy starts moving down like a lift, like an escalator. Okay? If it says this is minus 18, and when it says this plus 2, this is moving up by 2 points. So it's like the button of the escalator, right? You are on level 1. You say I want to go to level 3. So you say in your mind, okay, if I add plus 2 more floors, that is when I go to level 3. So in the lift you directly have the option of pressing button 3. Here you have to do the math. You'll say okay fine. But to move by 2 floors, I will add 2 floors. Yeah? Everybody okay? Okay. So these are the 4 basic constructs that we have to keep in mind. It's not that we have to memorize, but we have to visualize. I have a parabola. What is happening with my equation? Am I talking about plus minus inside the parenthesis? I am about talking about plus minus outside the parenthesis. Yeah? Outside the parenthesis is movement in the vertical direction. Inside the parenthesis is the movement in the lateral direction. Yeah? Alright. Now let's look at the other 2 similar analogy that we had. That was this one. Okay. Y equals to minus fx and y equal to f minus x. So let's say my function is y equals to function of x as 4x squared plus 7x. Okay? If I go for another function which is function of minus x, what will happen? And we can solve it. I can solve it. I can put different values. I can solve it. I'm asking you guys to visualize what will happen. Or another situation, another function where it is negative of function x. What will happen? So this is my original function. If I change the value of x from x to minus x, meaning in this equation everywhere wherever I have x, that becomes minus x. Let's say this one was plotting a parabola like this. When I go for this option, what happens? it will flip your parabola against this x-axis. It becomes like this. Now let's look at a scenario. Let's look at this scenario. When x was, let's say, 2. In this case, what was the value? When x, or let's look at when y is equals to 0. What is the value of x? It's x into 4x plus 7. So x equals to 0 and x equals to minus 7 by 4. Okay? So these are two cases where it touches the x-axis. Okay. And okay, yeah. And what will be the x coordinate of the vertex? Let's assume it's b by minus b by 2a. Same thing. Minus b will be what? Minus 7 by 2a. 2 into 4, 8. So it's minus 7 by 8. Now we are saying y equals to minus x. So my equation becomes y equals to 4 into minus x square plus 7 into minus x. So this becomes 4x square minus 7x. And what will be the x coordinate here? X coordinate of the vertex minus b by 2a, minus b, so minus 7 by 2a. Yeah. So it becomes 7 by 8. Here it was minus 7 by 8. Here it is 7 by 8. So what's happening here is, it's not moving against the x-axis. It's moving against the y-axis. Okay. So my vertex was here because my x coordinate was minus 7 by 8. So somewhere here. Now it became plus 7 by 8. Everybody is confused, and that is the main purpose of this one. Okay. So look at this one. If my x becomes minus x, if my function is y equals to function of x as 4x square plus 7x, if I change x to minus x, what happens to my parabola? It takes a mirror image against the y-axis. That is exactly what we have in the message that I sent to you guys. If you look at this one, right? I had also forgotten what I was saying. The graph of y equal to function of minus x is the graph of function s reflect across the y-axis. Now let's look at the first one, when y equals to minus function x. So okay, let's come back to build the understanding. Okay, so far what we saw, function of x plus c inside the bracket or function of x minus c inside the bracket makes the parabola move laterally, left or right. Okay, yeah. When I'm saying, when I'm adding in the function, adding a constant value, meaning function of x inside the bracket and then outside I'm saying phi, that makes my parabola move upward or downward. If I'm adding positive, it's moving it up. If I'm subtracting, it's moving it downward. Yeah. Now we are talking about another phenomenon where, so thanks to Pratik has given me a formula for proving all this. Okay, that formula is not 100% correct, but that is still helping. So now we are talking about if my function is function of x as something, let's say 2x square plus 6x plus 8. If I change a new function which is function of minus x, what happens to my parabola? If this equation was drawing this parabola, if I go for minus x scenario, what happens? We just saw it creates a mirror image against the y-axis. Y-axis. This is minus. This creates an image against the y-axis. Now let's look at it again. Let's say in this case, what is the new equation? Function of minus x will be 2 into minus x square plus 6 into minus x plus 8. So this becomes 2x squared, this will be positive, 2 plus 6 into minus, so minus 6x plus 8. Yeah? Now here, what is the x coordinate of my vertex? Let's go by same formula, minus b by 2a. Okay? In this case, what is my x coordinate? It is minus b by 2a, so minus 6 by 2a, 2 into 2, 4, 2 into 2, so it is minus 6 by 4, okay, x coordinate. Now, in this case, what is my x coordinate? Minus b by 2a, so b is minus 6 here, okay, so this is the x coordinate for the second function, and this is 6 by 4. Here it's minus 6 by 4. So it was somewhere here. It became plus 6 by 4. It came here. So now what you are saying is, in your function, if you are inversing x to minus x, it creates a mirror image against the y-axis. Your y-axis becomes a mirror. Yeah? Now, what will happen if you change your function to minus this? It will move it against the x-axis. There is nothing to be proven here, okay? I am not doing it because I will do the same thing, minus b by 2a to find out the vertex, and you will see that here the x value will not change. We will have to look at y value actually. You will put the x value in this equation and this equation to find out the corresponding y, and you will see y changes from positive to negative or negative to positive. Okay? So, what is that we have learned so far? It is the visual aspect of how you look at your quadratic function and how do you interpret based on that. Okay? First thing so let's do a quick recap. And trust me, you guys are learning it. Yeah. Little louder. But that is just a coefficient. See, you have to look at it this way. Okay, let me write it down first and we'll come to that. So we looked at 7 scenarios, okay? We looked at when my function is, let's say, 4x squared plus 6x plus 18. Whatever function it be. It's a quadratic function, that's it. It draws a parabola for me. Now, when I change function to function of x plus c, I am changing inside the bracket. So this is going to move my parabola in the lateral direction. Plus c is moving towards the left. Minus c will move it towards the right. Okay? That is one thing. And trust me, these are the easiest of the questions that will come in SAT, okay? You will not have to do any math. You have to just recollect your visualization and find the right answer, okay? And if I am talking about a function with with a constant added towards the end, it's moving it upward or downward. If it's positive, it moves up. If it's negative, it moves down. Okay? Everybody with me? Danusri, a third? Yeah? So, I mean, again, trust me, I keep on looking at your faces, okay? I keep looking at everybody's face. And when I see you guys are confident, I can read it. When I see question mark on your face, that makes me, kind of explain that one more time, okay? So, keep your video on. That gives me a lot of clue actually, okay? Alright. So, this is the four scenarios. Now, the other one that we saw was, if my function changes to minus this, it is making my parabola flip against the x or y axis. If the minus is inside this one, this is flipping against the y axis. If it is outside this, it is flipping against the y axis. Okay? Sorry, x axis, yeah. I mean, this is my x axis. So if minus x outside, this flips against that one. If minus x is inside, it flips against my y axis. Yeah? It just creates a mirror image. Up to this much is clear? Okay. Now, so Isha, I'm parking your question for next class because there are some more concepts I want to finish off, and then you will see that those questions are easy peasy, okay? Alright? And I'll be honest with you guys, okay? This is the only chapter which made me study so far in the whole SAT, okay? Every other chapter was very easy. I used to spend 5 minutes to go through it, easy. This is the one which made me study. So that means this will make you guys also study. It might take a little extra effort to be thorough with this one. That's why we are spending more time here. All the chapters, you will see that those are things that you already know and a bit of practice, but this is going to be much more demanding from SAT perspective is what I have seen personally. Okay? Now, so we looked at these ones. Let's go to other topics that I had mentioned in my, so we have 10 minutes, we should be able to cover a few more topics. Okay? Everybody is able to follow me so far, right? Vaibhav, Sivatsav, Dhanushree, Athar, Rutvik, yeah? Sunil? Okay. So what was the next one? Understanding quadratic formula to solve equations. So now, let's say if I have a quadratic formula, quadratic function or quadratic equation, let's say 4x squared plus 6x plus 18 equals 0, and you have to solve for this one. You know that there are two ways. One way is you try converting that into a plus b or a minus b form. Yeah? And then find out the possible values for this one. Second option was a into b, ab. Meaning you broke the middle term into two pieces and sum of two things, where the coefficients multiplied will get you this thing. Right? That was second option. There is a third option which is more like a silver bullet. You don't have to do anything. You can blindly apply the formula and find out the possible answers for x in a quadratic equation. If you are looking at the standard form, ax squared plus bx plus c equals 0 as a quadratic equation that you have to solve for x, the value of x is minus b plus minus b square minus 4ac by 2a. This gives you two possible values of x. One when you are taking plus as an example, one when you are taking minus as an example. So if you have a quadratic equation like this and you have to solve it for x, this is your formula, b square minus b plus minus square root b square minus 4ac by 2a. Where a is the coefficient of x squared, b is the coefficient of x. Hello Aditi. Because you are 7 minutes early in the class, we have senior kids doing SAT preparation, okay? So join after 5-7 minutes, you'll be fine. Okay? Okay, all right. So this gives us, you can just substitute the value of A, B and C in this equation, you'll get the possible value of F. Now few things to note here. B square minus 4AC, this is called the discriminant. This is called discriminant because this is the one who discriminates. This is the racist guy, okay? Who creates difference between the positive and negative scenario. Okay? If this is 0, if this guy doesn't exist, there is no racism. There is only one answer. Okay? If this guy, meaning B square minus 4AC, this is equals to 0, there is no discrimination. There is no, for lack of a better word, there is no racism. There is only one answer. Because this doesn't come into play then your answer is minus B by 2A. There is only one value for X. So this plays an important role. If the discriminant is 0, you get only one answer for the quadratic equation. If the discriminant is greater than 0, that is when the square root will give you some value. Okay? And then you will have two solutions for this equation. Meaning you will have two possible values of X. And imagine a third scenario when this is negative, meaning this is less than 0. Meaning square of B is greater than 4AC. If this is negative, the square root of a negative has no meaning. This is an unreasonable state. So when this is negative, meaning the discriminant is negative, there is no solution for this equation. So if somebody says, solve this quadratic equation and find out the possible value, first thing you will do is find out this value. If this is 0, then you find the value as this. If this is greater than 0, you have to find out the square root of this one. If this is negative, you will just surrender and say there is no answer for this one. Okay? Yeah? So that is why this guy is such a hated guy and called a discriminant. Because this guy discriminates the answers. Okay? This guy decides the possible answer for solving the quadratic equation. Okay? I would not want you guys to hate this guy. This is a cute guy. This gives you a lot of clue for solving this sum. But this decides how it will be solved. Okay? Alright? So now if you ever come across a quadratic equation that you have to solve, you have three ways of solving it. You will try relating that with a plus b, a minus b whole square formula, factorize it, solve it. If that is not working, you will try second option where you will go for a plus b, ab. Okay? And third option is when nothing works, just substitute the value and find it out. And then first thing you will do is if you are being lazy, that is good. Because when you are being lazy while doing maths, it makes you smarter. You find out easier shortcut methods for doing it rightly. So if you are being lazy, you will not do the whole calculation, you will only look at finding this one. And if you find this as greater than 0, then you don't have an option of being lazy, you have to solve it. If this is less than 0, you will say, okay, I'm done, I'm not touching this. If it is equal to 0, then you have to only find it. So this was the second thing that we had to learn. Okay? Now let's look at the third one. Absolute value equations. Absolute value equations. This is something that we solved but in the previous class. But this is something which is related to a term called mod or modulus. Right? A minus B equal to 4 may or may not be right. Let's say if A is 4 and B is 8, A minus B will be minus 4. If A is 12 and B is 8, then it is 4. Okay? So At times we are not worried about the sign. We are only worried about the difference. Let's say between me and Praneet, our age difference is let's say 35 years. Okay? So people are laughing now. Even if you know my age, don't worry about it. Age is just a number. Okay, coming back to the point. So between my and Praneet's age, the difference is 35 years. Now whether you are subtracting Praneet's age from my age and getting 35, or you are subtracting my age from Praneet's age to get 35, the difference is 35. If you pick Praneet's age first and then put my age, it will be negative. If you put my age and then you subtract Praneet's age, that will be positive. You are not concerned about positive or negative. You are concerned about the difference. And that will remain 35. That is where, when you want to do away with the worry of positive or negative sign, you use mod. This just tells you the absolute difference between two numbers, or the overall final value for the equation. Let's say if you're talking about x 4x square plus 7x plus 9. Find out the value of this for x equals to 3 and x equals to minus 3. So if you have a mod, it gives you the final whatever value comes. When you put this, let's say if it comes 27, it will show you 27. If it comes minus 27, then also it will show you 27. So that's why it's called absolute value. It only tells you the absolute value without worrying about the sign of it. Yeah?
So, mod basically shows you how far away a number is from zero.
How far a number is away from 0, or what is the value of that number? Minus 50, minus 80, minus 75, or 50, 80, 75. We don't really care about minus all the time. Let's say I have, let's say 2000 debt. I will say minus 2000 is my net worth. Or I can always say my debt is 2000. So I'm just saying 2000 and I'm putting a term called debt, which is not a sign. So that is where, when you are concerned about the absolute value, that is when we use mod. Okay? So now this brings us to a point where we have, where did my phone go? Oh, it's here. So we have, so Kavyan and all the smaller kids, just give me 2 more minutes, we'll wrap up this class and then we'll start with you guys. Okay? So we looked at the discriminants, we looked at quadratic formula, we looked at absolute value equation, and now all that we are going to do with polynomial graph, quadratic and exponential word problem, everything is related to all that we have learned. We have played enough with the parabola. We have played enough with the quadratic equation. We know when we add or subtract something from the function, inside the bracket, outside the bracket, what happens to the parabola, how it moves. So we will solve the 4 problems in the next class, and I'm sure this time when we talk about it, it will be easy to interpret and solve actually for you guys, because so far we had not covered the basics and we were trying to solve it. That is where all were struggling, okay? And at least I was struggling. I was not able to make you guys understand in an easier, simpler way. So now since we have understood the concept, we are able to visualize everything with the function. I'm sure when we try solving those sums, it will be easy. Isha, since you have sent the questions, you can try solving it. Even if you're not able to solve it, don't worry about it. Just give it a try. Spend 5 minutes and see if whatever we have learned is helping or not. If not, we'll do it in the next class. Yeah? Alright? Thank you guys. Enjoy the rest.